Okay, welcome back. We are on day 3, so class 3, talking about data structures, and we are on module 4. So we're going to go ahead and do our deep dive into dictionaries, and we'll finish with a fun challenge and kind of see how we all culminates together, what we've learned so far. One thing I want to point out is dictionaries, they are unordered, so it's an unordered collection of key value pairs. Before Python, I think it was Python 3.6, before then, the way that values were stored in a dictionary were it's called hashed. They were stored based on the mathematical calculation of the key running through some algorithm, something like an MD5 algorithm, some kind of message digest. And the reason why we would do that is because we can make them really quick to retrieve. In fact, if you look up big O notation, Google, go ahead and Google big O notation, you can see that hashed items in a collection can be retrieved really quickly. I can grab them out really quickly. Now, there's other things that make them not as friendly, like they're not in an order. Like if I put them in a specific order, I do not get them out in that same order. But I can able to retrieve them out of the data structure really quickly. Dictionaries are key value. So I'll have a key, which is how I'm going to look it up, and then the value is what's stored in it. Values can be any objects that we want in Python. Keys must be of type that are immutable, meaning they cannot change over time. That allows us to make sure that they have integrity, but it also allows us to make sure that the keys don't dynamically change inside of a Python dictionary. So how do we define dictionaries? I'll give a quick example here. I'm going to go ahead and copy this and paste it into our code block here. And you'll recall we have our variable name, we have the assignment operator, and then we have a curly bracket. That curly bracket indicates that we're talking about a dictionary. It starts with a curly bracket and ends with a curly bracket. Then inside of the curly bracket, we're going to separate things by commas. So I have a comma here, so this is one item. I have another comma here, so these two things are another item. And then I have a third item here. Now, when I talk about an item, I'm talking about a key and a value pair. We separate keys and values from an item with the colon symbol. So the thing on the left, name in this instance, is the key, and then the value is the string of the name John. Here our key is the name age, and then the value is the age of being 25. So that's how we define a dictionary. And we can actually loop over a dictionary with our for loops. I can say for item. Well, we can say for key, actually. I'm going to say for key in my dictionary. Put our colon. Then we're going to have our code block and go ahead and print out our key. There you go. So that's how we print out the keys. I got name, age, and city. So there's a quick and easy way to define a dictionary. Now I could, if I wanted to have an empty dictionary, I could say, well, I'm going to comment this one out because, oops, that's not what I want to do. Let's run that again. Comment this dictionary out, and then let's create a new one called my dictionary. And I'm just going to do it with curly braces. Empty dictionaries have can start with a curly brace and end with a curly brace. And that's going to define an empty dictionary. So if I print out all the keys in that, there's no keys, so it prints out absolutely nothing. But I can add items in dynamically. So dictionaries are what we call mutable. I can add things to them. In fact, I do that by adding it with a key. So we're going to say name. And I'm going to give it the value that I want it to store. I'm going to say Jonathan. Then I'm going to copy this, and we'll go ahead and do this 2 more times. And I'm going to say, instead of name, I'm going to say age. And I'm going to put the value of 45. And then for city, we'll say, I don't know, we'll say Orlando. So now I could create my dictionary what we call when we construct it, or I can dynamically create it this way as well. So you'll see that I have the name, age, and city. And if I want to reference and get the value, not the key, but I want to get the value, I can just reference it right out of my dictionary. So I see my dictionary, and I pass it in the key. Again, remember, square brackets, when I'm constructing an object, creates a list. When I use it against an object already created, such as my dictionary, I'm referencing into that object to get something out of it. So this is how I'm going to get a specific item out of that dictionary. And instead of putting in an index, which is zero-based, I'm actually going to give it the key. So I'm going to give it the name here, and I'm going to get the values out this time. So I get Jonathan, 45, and Orlando. Right. So you saw how I inserted values, but I can also get them out that way, and I saw how I got them out with it this way. So that's kind of jumped ahead here, but that's how we access values in a dictionary, is we use those square brackets. I'm going to go ahead and use our same example here and bring it down here. One thing I want to add to this is I can only have one of each keys in my dictionary. If I have something with the same key, what it does is it doesn't add it to my dictionary, it overwrites the previous value. So if I added John instead of Jonathan, and I go ahead and run this code, you see Jonathan is no longer in my dictionary as a value. It was overridden or updated with the name John. So now you see John, 45, and Orlando. And it does maintain insertion order because I did name first, then I did age, then I did city, then I updated name. It's going to reference the original name and update the value. So that's why you still see the word John there. If I put age in front of name, and I run the same example, you'll see age gets first, then the updated name, and then the city. So we do maintain insertion order even after we do updates. So updates don't change our insertion order, they just update the value. That doesn't quite look right to me, so I'm going to go ahead and put it back how we had it before, just to make it make more sense. Okay, that's how we do updating values, so I kind of jumped ahead again. So we can modify values with by specifying the key. So if I copy my dictionary, let's go back to the original dictionary here. Let's go back down to our modifying values. So I can define a dictionary when I construct it. Instead of doing it with the curly brackets, I could do dictionary, parentheses, and close the parentheses this way as well. And these parentheses are not saying it's a tuple because it's associated with this keyword here called dictionary. And this is going to be a constructor call to the function called dict, D-I-C-T. And it's going to start with this parentheses, and everything that's contained between the two parentheses get passed into my dictionary constructor. So if I print out, so what did I do wrong here? I did something wrong. What do I got? Oh. Does it not like, oh, I must need to have the curly brackets in here to define it that way. There we go. So this is an optional call to the constructor. If I want to create a blank dictionary, I can say, I can pass it an empty constructor. And that gives me a blank dictionary, or I could say blank dictionary 2 is equal to curly braces. And then let's print out dictionary 2. Well, let's print them out both. There we go. So either method can create blank dictionaries. If I want to create a populated dictionary, the best way to do that is just with the curly braces and then the key value item separated by a colon, and then commas separate items that are going to be in my dictionary. Now, what if I dynamically create one? Let's do we create one on the fly, or when we construct it, we pre-populate it with things, but I can also add things dynamically later. So I can say, if I give it a key that doesn't exist, why don't I say zip code, and we'll say, I don't know, 90210. Now I print out my dictionary. You'll see that it gives us our name, age, city, and added in the key value pair of zip code and 90210. So we can dynamically add things. Let's do add the engineer. Copy it. And we'll hit copy that. Paste that in there and run that one as well. And now you'll see that it added both the zip code and the occupation. So I can have as many key value pairs in a dictionary as I want. Now say I want to remove one. I can say, let's remove out age. So I can say del, which is a reserved keyword. See how it gets bolded in green? Then I'm going to give it my dictionary. And I'm going to give it the specific item. And we index in to get that item with the square brackets, and then I'm going to give it the key. So let's say age in this case. And when I run it, you'll see that now age was taken out. I have name, city, zip, and occupation. It no longer has the key age. Sorry. So that's what the deletion of an item does. Some very important methods that we can do. Let's actually grab our example again, come down here. I can grab out various methods outside of my dictionary. So let's copy this. And if I hit the dot and I hit my tab key, it shows you all the things that I can do, all the different functions that I can call. Right? So I can get the values, which is going to give me, I'm going to go ahead and print just the values. And you'll see I get John 25 in New York, so that's John 25 in New York. Those are my values. I can also get the keys. Gives me my name, age, and city. That's the key part of it, right? Name, age, city. And then the last one is items. And you'll see that we get name, John, as what data type. Go ahead and pause your thing and think about what data type it's storing them in as. So if we look at it, we have something here that makes it look like a list. And then we have something inside of it that looks like a tuple. So let's go ahead and see what type it is. You see it's actually a class called dictionary items. If I grab the first item, because I can index into it, right? Now I can index in using the 0th index, and I get a type error because I need to index into a dictionary item with not the number, but the keys, because it's a dictionary. Oops. I don't want to do items either. I just want to do into the dictionary and then figure out the type. I don't need the dot either. Causing all kinds of errors. There we go. And so my dictionary of the item and name gives us back our data type of string. What if I did age? That gives us back an integer because our age is stored as an integer. Okay, so that's getting out the keys, the values. Items, I use this all the time when I do for loops. So I might say for, I might say k comma v in my dictionary, and then I hit colon, and let's go ahead and print K, and then let's add some plus, well, let's just do K, and then we'll print V as on the second line, and then I'll do a space between everyone, so I'll just do a print with nothing in it. So this code block is actually 3 statements because they're all indented to the same level of indentation. I'm referencing my dictionary.items, and when I reference the dictionary items, when we saw that up here, where did I delete that out of here? I must have. Let's create one real quick just so we can look at it. Copy our dictionary just so we have it associated with it. And you'll see that the actual items themselves are tuples. So I can do what's called, well, we could just do it as one, we could just call it item. And then I can say K comma V equals item. And now it makes a little bit more sense on what we're doing here. So if you recall back when we did the tuple video, if item is a tuple, the key and the value are what's called tuple decoupling. So now I'm storing them as the key and value. And I'm taking them out of my tupled item, which is the key value pair. So go ahead and run this, and you'll see that I've got them key value, key value, key value. Now, I did this way to show you how it works out, but I could tuple decouple right inside my for loop. So I don't really need to do that 2-step process, but I wanted to show you what was happening there. So I'm actually doing the tuple decoupling inside my for loop because my items is giving me back a tuple. I decouple it right here to the value K and count value of V. So that's my key and that's my value. So that prints it out. Okay, so that's a lot to take in for dictionaries. You will use them if you start writing Python code quite often. They are a great way to store data and a great way to manipulate and update data, especially if you're grabbing it from other sources, maybe over the internet or from a database. Dictionaries are a real convenient way to manipulate and store data. Especially things like JSON data, if you're familiar with JSON objects, which is JavaScript object notation. Because they're objects, they translate very well into dictionaries. All right, so I'm going to finish this lesson with our challenge for the day. This is Student Grade Calculator. I want to write a program that calculates the average grade for a group of students. The program should prompt the user to enter the names and grades of the students. Once the input is complete, the program should calculate the average grade and display the name of the students who scored above the average. So this is quite a challenge. Go ahead and pause the video and see if you can achieve this now that you know how to do different data structures, how to store data. We saw how to do input, how to convert from a string input and convert it to an integer, so we can do that with grades. We've seen how to loop, so if we had to do a bunch of iterations, if there's a bunch of students, we can do that as well. And once you've finished trying to attempt that, come back and watch the video and I will walk you through step by step on my process through this challenge. Okay, welcome back. The first thing we need to do is to get the total number of students that we're going to try to calculate. So let's go ahead and request that from the user. We're going to do an input statement. How many students in the class? Now I want to get that as an integer for my loop count. So I'm going to say num students. And I'm going to convert this to an integer because it comes in as a string, so I'm going to convert that to my integer. Now I have the total number of students. So now I can do a simple for loop. For I in range of the number of students we have. Now I'm going to create my code block with my colon and then enter. So once I get into my code block, I got to get the data for each student. So now we're going to have to request the name. So we're going to do our input. Student name. We'll call that name. Then I got to get the student's score. But I want to store the score as an integer value, so I'm going to have to wrap this entire input statement in the int constructor. So parentheses here, close out the parentheses there. So now my int statement is completely, or so my input statement is completely wrapped and passed into my integer constructor to give me back an int score. So now I have the name of the person as a string and the score as an integer value. What I need to do now is I need to store this for calculating averages later. So let's just create let's create a list. We'll call it grades. Grades list, and we'll just make it an empty list. And we'll go ahead and put our score into that list. So we'll say, we'll do it singular here, grade list. Grade list dot append, and we'll say score. So now I'm storing the score in a list, but I need to store this individual name of the student paired with their score. So what data structure is good to store a key of a name and then a value of a score? Hopefully you said dictionary, so we'll say we'll call this the grade book. And we can define it as an empty dictionary. We'll say dictionary, open close parentheses, and that gives me an empty dictionary. I could also do curly brackets, open close, either one works. So we'll leave it as our dictionary there. So we're going to, now in the same code block, we're going to append into our dictionary based on the key of name, and we're going to assign it the value of their score. So once I'm done with this, I should have my entire grade book as a dictionary. So let's go ahead and just print this out as a short midway through our challenge, right? Just to see kind of where we're at, how it's looking. So let's say how many students there are. We'll say there's 3 students. We'll say John, and he got a 75. We'll say Jill, and she got a 98, and we'll say Mark. And Mark got a 69. No, we'll say 64. I don't know, just, there we go. So I printed it out. So I know I have it storing correctly. I should probably also print out the list of grades, but we don't need to do that since we know that the dictionary has the grades in there correctly. We know the score should be in our list as correctly as well. All right, so go back to our challenge. It says we need to calculate the average grade for the group of students. So how do I calculate an average? Well, we could go to Google, or we could try to memorize or remember how we calculate averages. What I'm going to do is a simple for loop. For grade in my grade list, I'm going to go ahead and sum a total grade. Here we'll say total grade is equal to 0. So I'm going to now say total grade plus, we'll just say equals total grade plus this new grade that the student has, and that gives me my total grades score. And if I do an average, I just have to divide the total grade by the number of students. We can do our simple division, and how do we get the total number of students? We can take our dictionary and pass that into the len function, L-E-N. So this gives us the average grade. So let's see how that looks. We'll go ahead and print that. And I'll give myself a little bit more white space so we can just see what I'm doing now, right? All right, we're going to say the same 3 students. John had the 75, then we had Jill, and I think she had the 98, right? And then we had, where did Mark go? There's Mark. And Mark had the 64, that's what Mark had. There we go. So the average of those 3 is 79. So the next thing we need to do is go through our entire list, our entire dictionary, and find every student that is above our average grade. So now we can store this as a variable. We can say so we could do another loop. So we're going to do a for loop. We're going to do k comma v, in our dictionary, which is our grade book. And we're going to go ahead and print out, but we're going to do an if statement. I'm sorry, we're going to do an if statement first, right? If the value, which is our grade, is greater than the average grade, we are going to print out the student's name, which is the key in our grade book. So this should now print out Jill's name if I keep the same data. So we'll go ahead and try to run and keep the same data. Oh, I did something wrong. Oh, I forgot to do item here. Remember, this will give back just the keys if I don't do anything. I have to tell it items. And it's a method call. In fact, if I forget what it is, I push the dot, and then I hit the tab button, and I look for items. There it is. And it is a function call, so I have to do open, close parentheses. And what else did I miss here? Oh, I didn't do a code block. There we go. Forgot to do my colon, and then this needs to be indented 4 spaces, because this is what we call a Boolean expression, because I'm using the math operator greater than. All right, we're going to say there's 3 students. John, the 75. Jill had the 98. Mark had the 64. Oops, I did Mark 64. We'll just put 64. So his name is now Mark 64. All right, so it printed out Jill because she's the only student that was above average. We can make this a little prettier. So let's go ahead and do code refactoring. The first thing I can do is get rid of my grade list, right? I don't really need that because I'm storing it all in our grade book. So here I was using grade list, but grade list is the same thing as gradebook dot values. Okay, so now you can see that got the exact same functionality stored in that. Now, this is prime for doing in, we could do something like this in our, what's the method that we learned earlier called comprehensions. I could streamline this and do this as a comprehension, right? What I could do, let's do the comprehension down here. I could say something along the lines of name for name comma grade in our grade book dot items if grade is above the average. And this is going to give me back what data type? It's in square brackets. Yep, that's going to give me back a list. So I could print out the list here, and that eliminates this 3 lines of code. Now let's talk about trying to eliminate some of this code to make it refactored as well. What if I did this running total in the same loop that I'm getting the student's information? So I could just say total grade is equal to total grade plus the score. So now I don't need this anymore, but I still need my average calculation because I still need to calculate the average. But I could calculate the average dynamically. So I can grab this, cut this out. Well, let's just see if this works first, right? How many students? We got 3. We got John with a 75, Jill with a 98, and Mark with a 64. And I've got something wrong, so let's see here. Oh, I gave Mark as the student score, and I did Jill. I see I've got all kinds of wonky doodled up there. Let's redo this again. 3 students. Student name, John. John's score, 75. Student name, Jill. Her score, 98. Then we got Mark. And Mark got a 64. There we go. And now I printed out students with above the average. I should probably print out the average. So we could print out this average. Clean up my code a little bit here. All right, one more thing I wanted to do to clean up that we've also seen previously done is I could, instead of doing this total grade equals total grade plus score, we saw that Python has this special feature where I can do plus equals and then just add the value that I want to add to it. So total grade plus equals score will just add score's value to total grade and increment total grade. Okay, so let's see this work now. Oops, I did 4 students. That was a mistake, but we'll run with it. John, we'll give John a 79 this time. Jill is still our A student. She still gets a 98. Mark gets a nice whopping, he studied this time. He got a 75 also, or 75 this time. And we got a new student, Sammy, who is a rock star and got a 100. There we go. So the average is 88, and both Jill and Sammy were above average. So we're starting to look a little cleaner, but I still don't like the fact that I don't know what these outputs mean. So I'm going to teach you one more cool trick that we can do in Python, and it is called an F string. So I've taught you strings, but I haven't taught you F strings yet. F strings are what's called formatted strings. I could say something like average grade, and then I can put curly brackets, kind of like we're defining a dictionary, but again, these things can be used for multiple different things. When we're defining a dictionary, that's used for defining a dictionary. When we want to do it for F strings, it means we can put expressions in our string. So I can actually put our expression here, and it's going to calculate it, the average, and then it's going to print it out with the average grade and be part of our print statement. So I can also say average grade. I can do an F string here, and I can say students above average, and then I'm going to put them here surrounded in our curly braces, not defining a dictionary, but here I'm defining the expression that I can run inside my f string. All right, last time running through this, we're going to say 4 students. John with a 79, worked really hard. Jill studied more, she got 100 this time. Mark slacked off and only got a 55. Sammy, no longer the valedictorian, he only got a 97. All right, so now you'll see average grade of 82.75, and then the students that are above average were Jill and Sammy. So I've streamlined the code, made it a little more understandable, I hope. We did my favorite, which is list comprehensions, to figure out how to calculate to find out which students were above average. Remember how we did that? We did that with the expression. The expression here happens to just be their name, Jill and Sammy. We did it on a for loop, iterating over our grade book items, and we did tuple unpacking of name and grade. And we did our conditional statement, so it only executes our name expression if the grade is above the average grade. So hopefully with that, you've seen how much you have learned in Python in just a few days. This is a really powerful language, and we're only on day 3. We got to go through day 10. So hopefully you're learning a lot. This is starting to make sense. It's starting to click. The best thing you can do is get hands-on keyboards, try these exact same scenarios out, run through these challenges, and just hopefully it's starting to make sense. If not, practice at it, watch the videos again. It will start to make sense. All right, I will see you for day 4.